Good morning, everyone. This video, we are talking about linear modeling. The focus of this section is to understand linear functions. Let's look at the definition. A linear function has a constant rate of change and a straight line graph. So let's talk about what is the rate of change. We know function describes the relationship of the two variables, x and y. X is the independent variable, y is the dependent variable. Functions describe the relationship of the two variables. Every function is different. Each function has its own pattern. The pattern determines how does y depends on x. How does y depends on x? And we know y is dependent variable, so the change of y depends on the change of x, right? So I think I want to give you a simple example to explain rate of change. Notation-wise, rate of change can be written as delta y over delta x. The delta here means change. If you learn engineering, physics, you would see those notation. That means change. Rate of change, rate is a quotient, right? Rate of change actually here refers to the change in y over change in x. Let me give you a very simple example. Let's say the function here, the independent variable is the time in days, and the dependent variable is the money I'm going to give you. I just made it up, okay? So let's say the way I pay you is every day, the first day, let's say today is the first day. For today, the first day, I give you $1. I give you $1. And tomorrow, I'm gonna give you $3. So every day, as every day passes, the money that I give you gonna be $2 more than the previous day. Okay, $2 more than the previous day. So the first day I give you $1. Second day I'm gonna give you $3. Third day I'm gonna give you $5. Each day the money that I give you gonna be $2 more than the previous day. So do you see the pattern? Then day 4 I'm gonna give you $7. Day 5 I'm gonna give you $9. Day 6, you would understand that, right? You should see that already. I give you $11. Let me double check. So for each change, for the change of x, this is x, this is y, right? The independent variable here is time in days. Dependent variable here represents the money that I give you. I'm gonna prove to you, I'm gonna show that to you. I'm going to show you that this is a linear modeling, linear function, because for the increment for the time in days, every time 1 day passes, the change in the money that you receive is $2. Every time 1 day passes, the change in your money, the increment in your money that you receive is $2. For 1 unit increment in the independent variable, the increment in the dependent variable, $2. So the change in y, if the change in x is 1 day, then the corresponding change in y is $2. It is a constant. So this is a linear function. If I graph the function, day 1, As x equals 1, y equals 1. As x equals 2, y equals 3. As x equals 3, y equals 5. So you can see every time your x increases 1 unit, your y increases 2 units. Okay, so you would have all those points. Those points are collinear. So that is a linear function. Am I clear about that? I think this is a good example. It's very simple, straightforward. Could help you to understand what is the rate of change. Rate of change simply is just the change in y over change in x. Since y depends on x, delta y would depend on delta x. Delta y actually incurred by delta x. The change in y is because the change in x. We have 3 bullets about the linear function. Number 1, the rate of change is equal to the slope of the graph. We know the graph of a linear function is a straight line, right? Well, a very important feature about the straight line is the slope. Slope is defined as rise over run. Remember that. Rise over run by common sense. When you look at this thing, when you go from this point to this point, this is your rise, right? When you go from this point A to point B, the horizontal change is the run, and the vertical change is the rise. That gives you the slope rise over run. And actually the run is the change in x. The rise is the change in y. So rise over run, that is the change in y over change in x. That is the rate of change. Can you connect them together? They are the same thing actually. Bullet number 2. The greater the rate of change, the steeper the slope. We understand that, right? So the slope could be very deep. For one increment in x, the increment in y is a big number, so that is very steep. If for one increment in x, the increment in y is very small, then you would have a flatter, very mild slope here. Bullet number 3. Calculate the rate of change by finding the slope between any 2 points on a graph. So I'm going to show you the process for finding or computing the value of the slope for a given straight line. The straight line represents the linear function. This graph shows you a linear function. The baseline represents the independent variable. So we plot the independent variable values in the baseline, on the baseline, and we plot the dependent variable values in the y-axis. From point 1 to point 2, this is the change in x, horizontal change, right? Horizontal change. And because that change, we have the corresponding change in y, change in dependent variable. So this over this, that's the slope, or that's the rate of change, and or that's the slope of the straight line. Anyone, if you have taken Algebra 1 class, you would know this equation actually is the equation of a straight line in a slope-intercept form. Slope-intercept form. The reason we named the form slope-intercept form because we are able to identify the slope and the intercept directly from the equation of the straight line. The coefficient m here is a number, okay, is a constant. X and y are the only variables. X is the independent variable. Y is the dependent variable. In the function, dependent variable y is by itself on the left-hand side. The coefficient of x, the number which is associated with variable x, that is the slope. 0, y is the y-intercept. If we make x be 0, we would have a y value equals b, right? So the point 0, b is the y-intercept. What is the y-intercept? Y-intercept is a point at which the straight line crosses y-axis. For example, this straight line in red, it crosses y-axis at this point, right? That point is the y-intercept. X coordinate is 0 because the point is on the y-axis. Y coordinate is bigger than 0 because the point, the y-intercept, is above the baseline. And this blue straight line has a y-intercept 0, 0. The y-intercept happen to be the origin. It crosses the y-axis at 0, 0. B equals 0. And this black straight line has a y-intercept 0, b. The y-coordinate of the y-intercept b is less than 0 because the y-intercept is below x-axis. And when we look at the three straight lines, we know they have different y-intercepts, right? But they have the same slope. Slope determines how do the straight line go from one point to the other point, the direction. You can see the steepness, where slope could describe the steepness of a straight line. You can see those three straight lines have the same steepness. They are parallel. In mathematics, in algebra, we know if the straight lines are parallel, then they have the same slope. So the three straight lines, these three lines, all have the same slope, but different y-intercepts. And those three straight lines, they have the same y-intercept, 0, b, but different slopes. The straight line in red has a slope positive because when we look at the graph from the left to the right, so when you read a book, you go from the left to the right? The same with reading a graph in algebra. When you are reading a graph, you go from the left to the right. If you see a straight line going up, then the slope is positive. If you see a straight line going down, the slope is negative, less than 0. If you see a straight line horizontal, flat, then the slope is 0. What if you see a straight line vertical? The only correct way to describe the slope of a vertical straight line is undefined. So let me repeat that. When you read a graph, when you read a straight line, you go from the left to the right. If you see the straight line going up, slope is positive, bigger than 0. If you see the straight line going down, the slope is negative. If you see the straight line horizontal, flat, slope is 0. By the way, slope equals 0 doesn't mean no slope. Okay, that is the incorrect way to describe that. Slope equals 0 means it has a slope. The value of the slope is 0. For the vertical straight line, the slope is undefined. Let's see the package in this section. For questions 1 through 6, use the graph shown, which shows the concentration of a substance in parts per million, so ppm, as a function of the time. So you can see the two variables. We're going to look at a function describes the relationship of two variables. One variable is time. The other variable is the concentration of a substance, maybe in your bloodstream, right? We had a similar problem in previous section. So those two variables, you know, because we talked about this before, time would be the independent variable. As time passes by, the concentration is changing, right? Concentration is changing. So concentration of a substance in ppm turns out from the graph is increasing. I don't know what kind of substance this is. So as time goes by, the concentration of a substance is increasing because the straight line is going up, right? So let me erase those, then we can see it better later. So this is the part of the straight line actually. Independent variable is time. Dependent variable is the concentration in ppm. We are given a linear function, a linear modeling. Number 1, what's the concentration on day 6? Independent variable x, assume the value day 6. So x equals 6. So let's look at the horizontal scale. Day 6. This point on the straight line has x value day 6. Then what's the corresponding y value? 4, right? So 4 ppm. The concentration on day 6 is 4 ppm. Is understandable? Number 2, what's the rate of change? Then we are looking for slope, right? Rate of change. So let's see. For convenience, we can consider those 2 points. If we consider going from A to B, the change in x is 1, 2, 3, 3 units, right? 3 units actually how many days? That is 6 days. From day 6 to day 12, that is 6 days. 6 days. 6 days. During or over the 6 days, the concentration goes up by how many units? 1 unit. 1 ppm. Do you understand what happened? Why do I choose A and B? Because they are just convenient. You can choose those 2 points if you want, okay? I choose those 2 points. If I go from A to B, then the change in the variable x, change in time would be 6 days. Be very careful. You see 3 units, but actually it's 6 days. Day 6 to day 12. 6 days. Over the 6 days, the corresponding change in the concentration is 1 unit up. So 1 over 6. So the slope is 1 over 6. Number 3, how much does the concentration rise over the duration of 3 days? Think about if the rise in 6 days is 1 unit, then in 3 days we're going to have half ppm, right? From number 2 we know every 6 days, because the rate of change is a constant. Every 6 days, the concentration increases by 1 ppm. Then in 3 days, which is half of 6 days, the concentration would rise by half ppm. So that is A, right? Part 4, number 4, find the initial value of the concentration. Initial value means initially, at the very beginning, as the time equals 0. As the time equals 0, this point has x value equals 0. The corresponding y value is 3. 0, 3 is the y-intercept, right? So we're gonna connect the initial value of a linear modeling problem as the y-intercept of the linear function. One more time. They are the same thing. The initial value of a linear modeling problem actually is the y-intercept of the linear function, because y-intercept has x value equals 0. If x represents time, then that's the initial value. So we should choose A, 3 ppm. Number 5, which is an equation representing concentration C as a function of time t. Okay, slope is 1, m equals 1 over 6, right? Y-intercept 0, b is 0, 3. So b equals 3. So we know the formula of the slope-intercept form of the equation. Y equals mx plus b. Let's plug in the value for m and b. Y equals 1 over 6x plus 3. Only this one is correct. You wonder why they write 3 in front of 1 over 6t, because 3, the y-intercept is the initial value. For a different point of view, they think that is more convenient for talking about linear modeling problem. So they write 3, the initial value, in front of the slope times x. Number 6, use the equation to predict the concentration on day 18. Then we just plug in t equals 18. We would have the concentration equals 6 ppm. Number 7, solve the equation y equals -4x plus 7 for x. Let me write that problem here. Y equals -4x plus 7. Solve that for x. Means we are going to transform this equation and isolate x on one side of the equation. So this is how do we do that. We firstly minus 7 from both sides. And we have y minus 7 equals -4x, right? We get rid of the 7. Now we need to get rid of the -4. We divide both sides by -4. -4 cancel -4. So we have x equals y minus 7 over -4. If we switch the two sides, we would have x equals y minus 7 over -4. Which one? A, right? Number 8, a country club charges a 30,000 initiation fee as well as a fixed 4,800 yearly fee. What would the total charges by over 6 years? So this is a linear modeling problem, a real linear modeling problem. We need to understand why this is linear. Because every year you have to pay $4,800 more every year. So here we have two variables, time in year and the money you pay, fees, right? Every year, as the increment in time is 1 year, then the increment in fees is a constant 4,800. That makes the problem a linear modeling. Let me say that again. We have two variables here. One variable is time in years. The other variable is the fees that you pay. As we have a 1 unit increment in the time, the increment in fee is 4,800. The rate of change, that is rate of change, okay? Rate of change is a constant. So we know this is a linear modeling. Linear modeling problem, the function, is y equals mx plus b, right? Or y equals b plus mx. B is the initial value. Initially, you need to pay 30,000 at the very beginning, up front. And the slope is the rate of change, remember. The change in the fee over the change in the year. Every year, you have to pay 4,800 more. So the rate of change or the slope is 4,800 x. Okay, so that's the linear modeling formula. And what are we looking for here? We are looking for what would the total charges by over 6 years. So as x equals 6 after 6 years, Let's see your pay, your fee. Y equals 30,000 plus 4,800 multiplied by 6. 30,000. And you figure out the value, okay? I'll leave this for you to figure out. That is D. Number 9, create a linear function relating x and y, which includes the points 5, 12, and negative 7, 36. Write y as a function of x. Alright, so that actually is a difficult problem. Number 9. We need to create a linear function relating x and y, which includes the point 5, 12, and negative 7, 36. We know two distinct points determine a straight line. So the 2 points are actually enough for us to determine the straight line, to find the slope for the straight line. Let's see how do we find the slope for the straight line. I have a 3-step method. Step 1, label x1, y1 for the first point. Label x2, y2 for the second point. Step 2, find the formula. M equals y2 minus y1 all over x2 minus x1. Slope is the rate of change in y over change in x. Value of y2, 36. Value of y1, 12. Value of x2, negative 7. Minus value of x1, 5. Let me double check. Be very careful when you plug in a number, especially when you have negative numbers. So we have 24 on the top. We have negative 12 on the bottom. So the slope is negative 2. Is negative 2. Okay? So the slope is negative 2. And so the equation, the function would be y equals mx plus b, which is y equals negative 2x plus b. But we didn't know what's the value for b. Let's figure it out. Choose one point from the 2 given points. I would choose this one because the numbers are more convenient. Because the point is on the straight line, the ordered number pair satisfies this equation. So when we plug in y equals 12, x equals 5, we should have a true statement. Then in this equation, b would be the only unknown. 12 equals negative 2 times 5, negative 10, plus b. And we have b equals 22. If you plus 10 to both sides, you have b equals 22. And that gives us the equation would be y equals mx, m is negative 2, x plus 22. Let's see which one is the correct answer. Slope is negative 2, 22. I think it's this one, right? Negative 2x plus 22. Okay, number 10, the last one. Use the function from question 9 to find the y value as x equals 8. That's easy. The function we got is y equals 2x negative 2x. Let me do it again. The function that we got from question 9 is y equals negative 2x plus 22. Now we know the x value is 8. Then plug in x equals 8. Negative 2 times 8 is negative 16 plus 22. You do the math, you get the number 6, right? So the corresponding y value is 6. Alright, so that's everything about linear function, linear modeling problem. I think we focus on understanding the concept of linear function, but it's also the same important thing is to understand linear modeling. I think number 8 is a very good problem for understanding linear modeling. I would recommend you look at number 8 multiple times. Alright, thank you guys. This is 9B. Thank you for watching. I'll see you next section.